This lesson we're going to talk about meters. Your meters will be one of the most often materials that you can get. So you need the first meter back in your bag, you need the last meter in your bag. This is a safety measure. Even if you're using a meter, there's two basic types of meters on it. First, you have your analog meters. Those are the most volts per meter. They're probably the ones that the powers of their pumps. So they're the first meters on the market. They're extremely sensitive. You do not stand upright. That's what it does. Sometimes they're still used today when you're looking for extremely accurate measurements. This is an example of a nice story. Needles are very fine needles with different scales, and then it's attached by this spring down at the bottom. Digital meters have almost gone completely replaced the analog meters in the industry. Digital meters stand up much better to reading watt, also reflect on a wide variety of temperatures. Digital meters are accurate and usually auto-read reads in the scales themselves. Examples of digital meters. There are several basic electronic rules you must understand prior to understanding what a meter is telling you. Most of the rules is based on voltage and resistance. Series. You will sometimes hear technicians talk about things in series with something else. Series means in the same line as. We're going to talk more about series circuit in the next section. But this is an example of a series circuit. The red ball is in series with the yellow, which is in series with the green ball. There's one path or one wire that the electrons will go. Parallel means next to. We're going to talk more about these. However, when we're talking about parallel circuits or things in parallel, there's like three paths in this picture for the electrons to flow. Some might flow through the yellow ball, some might flow through the red ball, and some might flow through the green ball. They're all parallel to each other. Open circuits are circuits that do not have a complete path for electricity to flow. These circuits require a source, switch, a path, and load. If any one of these components have a break, or a gap, or an open in it, the current cannot complete its circuit. This is an example of an open circuit. The switch, labeled SW1, is open, thus the electrons cannot flow across it. When you measure voltage across an open circuit, you will always get a reading of source. When you measure resistance across an open circuit, you'll always get a reading infinity, or most people show OL. So, voltage across an open is whatever the source voltage is. Resistance across an open is OL. A closed or complete circuit is one that has a complete path, source, switch, and load. The load is operational in a complete circuit. The switch is closed in a complete circuit. This is an example of the same circuit, but complete. We have our line and neutral, those are our source. We have a path, which is the wire. We have a closed switch at switch 1. And we have a working load. When measuring the circuit, the voltage across the switch in a complete circuit, we get 0. There's no potential between the two sides of the switch. When measuring voltage across a complete circuit, you will get source. Voltage across a load is identical if the load is working or if the load is bad. If you have all switches closed and measure voltage across the load, the circuit is good. If the load is not working, then you have a bad load. If the load is working, then the voltage you read is the voltage the load is using. The current or the amperage you measure in an open circuit will be 0. In a closed circuit, the amperage you measure will change based on where you take the readings. Meters will measure voltage, current, resistance, capacitance, frequency, and temperature. Voltage is the most frequent measurement we make. To measure voltage, turn your meter on and set it to volts or V, depending on what your meter shows. Make sure that your leads are plugged into the correct place on the meter, and make sure you have AC or DC selected. Put the leads in parallel with, that's in other words, next to the point of the circuit you're trying to measure. Hold the lead steady without touching any of the metal to your fingers or each other. Watch the number until the meter stabilizes on the number. That is good. So if we wanted to measure voltage across SW1, which is open in this case, we put the leads on each side of the switch. In our case, our meter would show 120 because voltage close the switch, that voltage is going to turn to zero because there's no difference, there's no gap in the path, there's no potential. Voltage across a non-powered load is zero. Voltage is stopping at SW1. There's no voltage going to load. Voltage across a powered load is 120. Now notice the complete wire inside of V1. That's a light bulb filament. So voltage across a powered load is source. But if I break that filament, now it's acting as an open switch. So now voltage across the load is still 120. The only difference is the load is not working. Voltage across the full circuit, line to neutral, is 120. Always source. Notice regardless switch open or closed, because if the switch is closed, that voltage would be zero, but the bulb would still have 120. To measure resistance of a circuit, disconnect the circuit from the source. With resistance measurements, there cannot be any power on the circuit because your meter provides the power. Decide what component or portion of the circuit you would like to measure. Disconnect the wires to or remove that part. Set your meter to ohms and touch one lead directly to another just to verify your meter. Should show as a reading of 0. If it doesn't, check your leads. Now touch one lead to each side of the component or an isolated portion of the circuit you are testing. Wait for the display to stabilize and record that number. This is the resistance. Resistance is shown in ohms. In this case, resistance across an open switch is OL, or infinite. There's no way electrons can flow through that open switch. Resistance across a closed switch is 0. Again, notice that that service switch up at the top left, right under the 120, is open. We don't want any power on this load. So resistance across a closed switch is always 0. Resistance across a good load will come up with some number, whatever the resistance or opposition to current flow that that load has. Resistance across an open load is OL, or infinite. There's, again, same as a switch. It's open. There's no way electrons can make it through that circuit. To measure current, the first step is determining which method you want to use. If it is possible, use the clamp for higher voltages currents. You can also, for low voltage currents, put the meter in line with or in series with the circuit. To measure current with the clamp-on meter, make sure the system is running. Clamp the meter around a single wire and wait until the number stabilizes. This is your amperage rating. For example, if the wire is wrapped 10 times around the clamp and your reading is 2 amps, then it's 2 divided by 10 or 0.2 amps. If the current is so low, consider putting the meter in line. That is not possible. Wrap the wire around the clamp 5 to 10 times and take the reading. Divide that number you get by the number of times the wire is wrapped around the clamp. In this case, you're measuring current in line. Your meter's in series with the rest of the circuit. In other words, there's only one path for the electricity to flow. Make sure the power to the circuit is turned off. Check with your voltmeter to verify this is the case. Disconnect the wire directly before the component you're concerned about and put your meter in series or in line with the component to complete the circuit. Make sure the meter is set to amps and the leads are plugged into the correct spots. Turn the circuit back on and allow your display to stabilize on the meter. This is your amperage reader. Make sure you know what the levels of voltage and current the meter is rated for. Never exceed this voltage or current. If you suspect that this is close, use the clamp-on method. Unfortunately, most of the time you will not just have one switch controlling this load. Most circuits in the HVAC industry will have one or more control devices. You must have a reliable, organized method to find problems in this circuit. This is why most good technicians start off any diagnostics by using the Hop-scotch method to trace circuits. The procedures for this is simple. First, make sure your meter is set to volts and make sure the leads are correctly plugged into the appropriate places on the meter. Next, check the voltage across the two endpoints of the circuit, line and neutral, or line and line, depending on the voltage. Next, put one lead at the start point of the circuit. In our case, we're going to use L1. You're not going to move that lead, so you might want to use an alligator clip or something to hold it there. Use the second lead to go from point to point in the circuit before and after each switching device and loads, checking for opens until you find the problem. An example of this, we check the voltage across L1 and N. That's 120. We know we have power to the circuit. If we didn't, we'd have to find out why. Now, leaving the lead on L, we go from L1 to the line side of switch 1. Again, line side of the switch is towards the source. So the wire, and in this case we get 0 volts, so the wire from L1 to S1 is good. Voltage across the L1 and the load side of switch 1 is 120. Right there we found an issue. Switch 1 is open. Remember, voltage across open switch is always source. So what you're doing as you're going through here, any switching device, you're looking for opens. Any loads, you're looking for power. You can verify the problem now starting with neutral. Leave your lead on neutral. Voltage from neutral to side of B1 is 0, wire is good. Other side of B1, no problem, voltage remains 0. Now go to line side of S1, same as before, 120. We verified switch 1 is open. You're going to now use your meter a couple times in the shop if you're working in the school. If not, take a meter and try to trace the circuit out in your house or business.